Hello guys, good morning.
Good morning, sir.
Good morning. Any questions from previous session, guys? Okay, so yesterday looks like we covered most of the security part, and we completed it actually. Okay, so let me share my screen.
Yeah, sir. Yesterday, SSL Ambari document, installation document. Can you please update the latest one in Drive?
Okay, sir. Okay, sure, I'll do that.
And explanation of the document as well.
Okay. So can you see my screen? Hello.
Yes, yes.
Yes, sir, we can see.
Hello.
So we can see your screen.
Yes, sir. We can see your screen.
Hello. Can you see my screen?
Yes, sir. Can you hear me, sir?
Can you hear me?
Yes, sir. We can hear you.
Yes, sir. Able to see your screen.
Hello. Can you hear me, sir?
Yes. Can you hear me now?
Yes.
Okay, it's better now. Okay, now I also can hear you.
Sir, explanation document also.
Document also. Okay, you want to? Okay, so right. I'll put right now. Okay, 1 second. Yeah. So, okay. Installation documents. I'm making some changes to the installation documents, guys. Okay, so mostly once that is done, okay, I'll upload. Okay. But if you want to upload these things, okay, so I'll upload. Yeah. Done.
Thank you,
Okay.
sir.
Okay. Okay. So apart from that, any other questions? If not, okay, we'll start with the cluster planning part today. Okay. So yes, till yesterday. Okay, real-time cluster. So okay, so apart from this, okay, what are some other tools? Area, Trina area. Okay. So I would say security area. When it comes to security, we have, okay, so LDAP already, okay. Kerberos, okay. Knox, Kerberos, after that, okay, Ranger, okay. So Ranger KMS, Ranger KMS. After that, what we have, Ranger KMS and Knox. Okay. When it comes to security area, so these are the things which we have seen. Correct or not, guys? Okay, when it comes to security area, okay, so these are the things we have seen. Okay, LDAP ID, authentication, okay, authorization, encryption, okay, gateway, all those things we have seen. Okay, so now, okay, let me copy all these things in one place. Okay, can I say this is my entire cluster, guys? Hadoop cluster. Huh? When I say Hadoop cluster, okay, you will have all these things in place. Okay. So can I say this is my real-time cluster? Okay. So this is my real-time cluster. Okay. So so this is the Hadoop area where you have so compute storage part. Okay, so this is the edge node area where you install most of the batch tools. Okay, and this is the UI area where you install your UI, and this is a Kafka area, NiFi area, Storm area, Spark area, ELK area, okay, Trino area, and so this is the security area. Okay, so all this together, okay, we say this is our Hadoop cluster. Okay, so now okay, we want to plan this cluster actually. Okay, we want to plan this cluster. How do you plan this cluster? How do you plan this cluster? Okay, first, okay, let us talk about the storage. This is the, see, out of all those things, okay, what is the major storage part? Even you take Kafka, okay, so finally the data will come and sit here. Okay, so Kafka, okay, NiFi, okay, even if you take Storm, okay, so ELK, okay, ELK, so it has its own storage, okay, leave it, okay, but end of the day, the access data will come and sit here only. Okay, so Trino area, even a Trino is kind of a query engine, okay, which will extract data from here. Okay, and okay, this is the security area which will provide security for the data storing here. Okay, so it means okay, this is the major area for us. Okay, storage and processing area for us. Okay, so now, okay, in this area, okay, how we can decide, okay, how we plan, okay, how many nodes are required in this area? That is the requirement now. That's the cluster planning now. Okay. So for this, okay, so I've given a separate document for cluster planning. Okay. Okay. So normally, okay, when I say okay, so Hadoop cluster, okay, so you take this. This is the Hadoop cluster. Okay. So when I say server, okay, so when I say server, inside this one, okay, so we have taken, okay, some hard disk. Okay, so as you all know that, okay, when I say server, okay, in one server you can add multiple hard disk. Okay, so the max, okay, up to 26 hard disk you can add. Okay, but okay, will you be using all hard disk in the cluster in a node for HDFS only? Or you will be using something for OS disk also. You take our servers only. Okay, you take our cluster only. Okay, so if you take our cluster, we have taken total 4 hard disks. In that one hard disk, okay, we have given to OS, and okay, other hard disk we are given to, we are using it for Hadoop actually. Okay, this is what we are doing. Okay, so in any cluster or in any server, if I have 10 hard disks, I cannot use all 10 hard disks for for Hadoop itself. Okay, so I need to use some hard disk. Okay, for some hard disk for what to say, for OS also, OS and other related stuff. Okay, so normally, okay, they leave around 20% disk for OS and okay others. Okay, and okay, the 80% of the storage. Suppose okay, if my total hard disk, okay, so let's say I have a server one. Okay, I have server one. Okay, so inside this one, okay, I have 10 into okay 10 1 TB hard disk we have. It means total 10 TB storage. Okay, in this 10 TB, 20% means okay 2%, okay 2 TB. Okay, will go for OS. Okay, and 8 TB will go for SDFS. Understood? Understood. 8 TB will go for SDFS. Okay, so it means around 20% of the storage will be leaving it for OS, and 80% of the storage will be using for SDFS. Okay, in this 20%, what will be storing? In this 20%, will be installing OS. Okay, we'll be installing OS. Okay, we'll be installing SDFS. Sorry, Hadoop okay, OS storage and okay, okay. This is 20%, 80%. Okay, so when I say OS storage, what you will have? This is Hadoop storage. Okay, so OS storage. Okay, so this is okay, we are keeping it like 20%. Okay, in this 20%, we'll install OS operating system. OS. Okay, OS installation. Hadoop installation. Okay, so okay, this is for okay intermediate job output. Okay, so all together okay, this will go like okay 20%. Guys, all together this will go like around 20%. Okay, so here so okay. So try to understand here, guys. Okay, so I have total 100% storage in that 100%. Okay, so the idea here is that to leave 20% to OS. Okay, and okay 80% for SDFS. Okay, so now okay, suppose okay, if I have 600 TB storage. Okay, if I have 600 TB storage, okay, I'll be leaving 120%, 120 TB for OS. Okay, not this one. Okay, don't take this one. Okay, if I have 10 TB storage, what I'll be doing? Okay, 2 TB for OS and okay, 8 TB for HDFS. Okay, so now this is the OS storage of 20. Okay, 120 TB. Okay, this entire 120 TB, this 100% of this entire 120 TB, I will be using for OS and Hadoop installation, Hadoop service to maintain okay, Hadoop service logs or application logs, intermediate job output, and any other. Okay, so why we are leaving this 20%? This is the reason. We're leaving 20% because okay, we need to install OS. Okay, then we need to install Hadoop. Okay, then we need to give some space for okay logs. Okay, we need to service logs. Okay, application logs. Okay, because application logs also initially they'll be written to local file system. Then they'll be merged and put into HDFS. Okay, and any other requirement. Okay, any others. Okay. Okay, any others? Okay. So this entire 120 TB storage we are using this purpose. Okay. But now going to HDFS storage. Okay, HDFS storage. Okay. So here what we are doing. Okay, this entire 80% of 80% of this HDFS means okay. When I say 80% of HDFS, this is 480 TB. Okay, in this 480 TB. Okay, we'll be storing total. Sorry, okay, forget about this 480 TB. Okay, in this 8 TB, okay, we'll be storing. Okay, replication 3, right? For any of your data, replication equal to 3. Okay, so first copy of your data, second copy of your data, third copy of your data. Okay, because okay, so this is a replication 1. Replication 2 and replication 3. Okay, so replication 1, replication 2, replication 3. Okay, so and around 30% free space should be always maintained here. Okay, suppose okay, if I have 8 TB data, in that 8 TB, 23% I'll be using for first copy, 23% I'll be using for second copy, 23% okay, I'll be using for third copy. So the remaining 30% space, okay, will be used. Okay, will be a free space. So it is one of the requirement, or it is one of the best practice to maintain at least 30% of the free space on HDFS at any point of time. Understand, guys? It is a best practice to maintain around 30% of the free space on HDFS. Okay, so it's okay. So as I told you, okay, the total storage is divided into 2 parts, major parts: OS storage and HDFS storage. Again, okay, the OS storage further divided into multiple parts, and okay, HDFS storage also further divided into multiple parts. Understood? Understood or not? Okay.
Yes, sir.
So now, okay, coming to this one. Okay, coming to this one. Okay, so okay, you take this one. Okay, this is my total hard disk. In this hard disk, okay, 20% will be giving for OS. Okay, 30%. Okay, and 80%. Okay, overall 80%. Okay, we are giving to HDFS. Okay, so this if you take the overall 80% as 100%. Okay, in this okay, free space on HDFS will be okay 30%. This is first copy of data, second copy of data, third copy of data. Okay. So this is what okay, we have. Okay, so now let us see. Okay, how do you plan your cluster, guys? First of all, how do you plan? Okay, so how many data nodes we want? How many name nodes we want? Okay, so how do you plan your cluster? First of all, okay, to start with, okay, where do you start? To start with, where do you start? Yes, you there or not there?
Daily, how much data we received, we can start from.
Is it daily or okay? So already whatever data you have. Okay. Suppose okay. Let us take this scenario, guys. Okay. So now, okay. Let's say if somebody want to build a cluster. Okay. So let's say some XYZ client. Okay. So he has okay his business. Okay, he's doing this business. Okay, XYZ bank. Okay. So XYZ bank has started in sometime in 1960. It started in 1960. It is running till now. It is running till now. Okay. So now, okay, this guy felt that, okay, so this guy felt that, okay, yeah, 1960. Okay. This guy felt that, okay, my data is growing daily. Okay. So existing sources of data are not sufficient. So let me migrate to Hadoop. Let me move it to Hadoop. Okay. Let me move my data to Hadoop. Okay. So what he has done? So he went to one architect. He went to one Hadoop architect and asked, hey, Hadoop architect, okay, so I have a bank and I have some banking data. I want to move this data to Hadoop. Okay. So what immediately he will ask? Okay, so to move to Hadoop, okay, I need a cluster. Can you please help me, okay, in designing the cluster? Okay. So what Hadoop architect will ask? So this guy is going to Hadoop architect. Okay. So now Hadoop architect has to give the plan. Okay. What Hadoop architect will ask immediately?
Yeah, what is the current data size?
Exactly. So how much data you have to move to Hadoop? So it means, okay, you said, okay, you have business from 1960, from 1960 to till today. Okay, you take, okay, till, okay, so till April 30th, how much data you have? That is the first question. Okay, there only your discussion will start. There only your discussion will start. What is your total data? Okay, so now, okay, so any company, okay, so now XYZ Bank will have an idea, right? What is the total data till now? Huh? Definitely, XYZ Bank will understand, okay, what is the total data we have, all banking data we have, all banking digital data we have today. Okay, definitely they will be having an idea. Okay, they'll be having an idea. Without having this idea, okay, nobody will go to architect. Okay, understand? Okay, so now, what is the first question architect will ask? Tell me, okay, so what is your data size? Okay, let's say this guy is saying that, okay, hey, I have, okay, so from last, okay, 40-50 years, okay, so 1960 we started 1960 to 2022, last 52 years, okay, I'm storing my data into RDBMSs. Okay, so now RDBMSs, then, okay, I pushed my data to data warehouses. Okay, so now all together, okay, I have, okay, 100 TB data. Or let's say 1000 TB data. 1000 TB data we have. Okay. This is the 1000 TB data what we have currently. This is one copy, or okay, will RDBMS maintain replication and all? No, right? No, right? Okay, so it will not maintain any replication. So he is saying, okay, I have 1000 TB of data. This is one copy. Okay, so what is the monthly growth? What do you mean of monthly growth? This is, okay, this is the data from 1962 till today. Okay, till April 30th. Yes or no? Okay, so it means, okay, for 52 years, okay, for 52 years, okay, so his data has gone up to 1000 TB. Okay, it means, okay, on average, how much monthly it is going? Okay, 1000 divided by 50. Okay, on average, monthly 20 TB data is coming. Will you agree with me? Huh?
Yes, sir.
Okay, so on average, okay, 20 TB is growing. Okay, on average, 20 TB is growing. Okay,
Yearly data, right, sir? Yearly 20 TB, right?
Not yearly, sir. Oh, 50 years, right? Okay, so okay, sorry. Okay, yearly 20 is growing, right? Okay, so okay, so 1000 TB divided by 52 years. Sorry, divided by 52 years. Okay, it means, okay, per year, okay, this much is growing. Okay, by 12. Okay, so nearly 1.6 TB. It means per month, how much it is growing? Nearly 1.6 TB. So let us take it like a round figure, 2 TB. Okay, so it means, okay, per month, okay, on average 2 TB data is increasing. Yes or no?
Yes.
Okay, so now the next question. Okay, so normally you are building a building a cluster. Okay. Okay, let us go talk about your house, guys. Okay. Talk about your house. Okay. So now go to an architect. Okay. Okay. So you want to construct a house. Okay. You will go to architect. Okay. So let's say Venkata. Okay. So Venkata will Venkata want to construct a house. Okay. So he will go to architect and ask, okay, hey, can you give me the plan? Okay. Okay. So here we will ask house plan. Okay. When I give house plan, okay, so what is the first question architect will ask?
Area.
Okay, so how much area you have? Okay, so what is your site measurement? Okay, so I will tell, okay, so I have 30-40 size. Okay, so let's say I have 1200 square feet. Okay, so 1200 square feet. Okay, square feet size. Okay, so what you will tell, okay, in this square feet, okay, so in this site, okay, will he construct, okay, full house, or okay, so he will leave something for, okay, parking. So for parking, you leave 20%. Okay, 20% space. Okay, so main house. Okay, parking and sites. Okay, 20%. Okay, so main house 80%. Again, okay, in this main house, okay, so again, okay, so in this main house, what and all will come here? Under this main house, okay, so you may be having a hall, okay, you may be having kitchen, you may be having bedroom 1. Okay, so like this, okay, so you may be having bedroom 2, so like this actually. Okay, so this is important. Okay, now, okay, so okay, when we are planning a house, okay, okay, let's say, okay, so Venkata has recently got married. Okay, I'm just giving an example. Okay, so at this moment only Venkata and Venkata wife, okay, only 2 people are there. Okay, since only 2 people are there, okay, will they go for only 1 bedroom? Okay, they think that, okay, in future they'll have kids, and okay, so kids need another bedroom. Okay, so will they plan, okay, for future also, or okay, they'll plan as per the current situation only?
Future.
Definitely they'll think about some future also, kind of they'll plan. Okay, so here also it is the same thing. Okay, so here, okay, so when you are planning normally, okay, here also, so they will plan, okay, current data plus, okay, future data. Okay, future data. Because it is the same thing, right? Okay, so current capacity and people plus, okay, future people. Okay, so current people means only 2, husband, wife. Okay, but okay, future people means maybe kids will come, or maybe, okay, parents will come. Okay, so we may require extra bedroom. Understood? Okay, so definitely when you are planning, okay, you will not plan only for today. Okay, or as per the today's situation. Okay, you will think about future and, okay, you will plan. Okay, so here also it is the same thing. Okay, when we are planning for a cluster, you will think about, okay, future also. Future is not like, okay, for next 10 years and all. Okay, so maybe in Hadoop, okay, the future plan is for next 6 months. Okay, it means, okay, your one copy is here. 1 copy is 1000 TB. Monthly growth is 2 TB. Okay, so if I plan this, okay, for next 6 months, okay, so extra 12 TB will come. Okay, now I will take the total data. I will take all your data is all your total data as 1012 TB data. Are you clear? Are you clear, guys? So now, okay, as an Hadoop architect, okay, you need to give a cluster plan for 1012 TB, not for 1000 TB. Okay, if you give for 1000 TB, it's for current plan. Okay, so we need to think future also for, okay, current plus 6 months, next 6 months. Okay, so on average, okay, you need to give a cluster plan for 1012 TB. Okay, so this 1012 TB is 1 copy. Yes or no? So if I put this 1012 TB as it is in Hadoop, okay, so this will be 23% here. Okay, this is first copy. Okay, then second copy, then third copy. Okay, so it means, okay, my HDFS itself, okay, I require, okay, first copy of 1012 TB, second copy of 1012 TB, third copy of 1012 TB. Yes or no? Okay, so after putting this one, okay, what is the best practice? Okay, plus 30% free space I required. Okay, why this 30% free space? Okay, so normally, okay, when you run on MapReduce jobs, or when you run any job, okay, so where the data will come and sit? Output data?
Local file system.
No, output data, final output.
HDFS.
Okay, final output will be an HDFS only. Okay, suppose, okay, if I don't keep any free space, okay, so you have the data. Okay, if I don't keep any free space, okay, where your output will be stored? That is one requirement. Okay, so suddenly, okay, some extra data has come. Where do you keep? Okay, so that's the reason. Okay, it's always a best practice to maintain around 30% of the free space on HDFS. Okay, so now if altogether, if I take it like 70%, okay, if 70% is 3036 TB, 30% is 1301 TB. Okay, so now when I say HDFS, this is all together. Okay, this one. Okay, these four together is called as HDFS. Okay, so now if I sum all these things, okay, what is the HDFS space? What is the HDFS space? 4337 TB. Okay, it means, okay, if I want to put 1012 TB on HDFS, I need to have 4337 TB of storage on HDFS. Okay, and this is okay, again, okay, so as per our rule, okay, HDFS will be 80% and okay, local file system will be 20%. Okay, if 4337 is 80%, what is 20%? 1084 is the 20%. Okay, so now, okay, so this is 80% storage and this is 20% storage. Okay, so now overall, if I say 100% storage.
Sir, every 6 months we need to review this plan.
Sorry?
Every 6 months we need to review this plan then? Yes.
Yes, every 6 months, okay, you need to review this plan. Because okay, I'm giving the plan only for next 6 months, right?
Yes, sir.
Maybe after 6 months, okay, you may have to think, okay, whether we need to add okay, extra nodes.
Okay, sir. Got it.
Okay. So now, guys, okay, try to understand. Okay, suppose, okay, if I want to keep 1012 TB data on Hadoop, okay, we need to have total space of 5421 TB on Hadoop cluster. Then only I can put this much data. Understood, guys? Okay. See here, okay, I'm going from bottom to top. Okay, I'm not coming from top to bottom. I'm going from bottom to top. Okay. If this is one copy, all 3 copies will become like this. Okay. If this is 70%, okay, this is okay 30%. Okay. If this is 100%, okay, this 100% is nothing but okay, 80% of HDFS. Okay. If this is 80%, then okay, this is 20%. Okay. So then altogether is 100%. Understood? Okay. So here, okay, so total space required is okay. Total space means okay, HDFS plus local file system space. Okay. Understood. Okay. Now we understood that okay, what is the total space we required? 5421 TB of total space is required for us now. Correct? Correct or not? Okay. So now go for this one. Now go for this one. Okay. Now this is the overall. Okay, so I'm putting okay. Total HDFS is 4337 TB. OS okay storage is 1084 TB. So total disk required is okay. Total disk required is okay 5421 TB. Okay. So now the question is that okay. So if I am buying servers for this one, okay. So now I need to think about okay, what is the total TB for single data node? Okay. So now let us talk about this server configuration. Okay. When I say server, okay, normally, okay. So any server, Hadoop server. Okay. So you will have 26 hard disk in each server on average. Okay. So by default, okay. So now normally you leave the first 2 hard disks for OS. Yes or no? Okay. So the remaining hard disk, okay, so these are the remaining hard disk, okay, SDA, SDB, SDC like this, okay, till SDZ, okay, SDZ, okay. Suppose, okay, if you say, okay, this is in use, okay, how much TB you will put? How much TB you will put it here? Huh? So you are putting 2 TB, 2 TB, 2 TB. Okay. So now, okay. So initially you put all, okay, all 10 2 TBs. Then okay, the next, okay, next 5 are, okay, 4 TBs. Okay. Next. Okay, these are, okay. So let's say connect all disk are this one. Okay. So you can put 1 TB also here. Will it say no? Sir, okay, this is a slot in the server. Okay. So I'm putting 1 TB here. Will it say no? If I put all 1 TBs, what will happen? Okay. Total, okay. My one node capacity is 34 TB. It means, okay, in one single data node, okay, single server, I have 34 TB storage. Will you agree with me? Will you agree with me, guys? Sir, okay. Maybe this is one reason, okay, where this batch is going to delay also. Okay, 45 people, not even 1% replying. Okay, fine, sir. Tomorrow onwards, I'll give the recorded session so you go and listen, sir. What is the use of? There is no use of live class, right? Okay.
Yeah.
If it is okay, interactive class, it will be good for you and for me also, guys. It will be easy. Okay. Suppose, okay, now, okay, if I keep, okay, all 1 TB hard disk, then, okay, then I can have 34 TB. Suppose, okay, if I'm not using this one, I'm not using like this actually. Okay, I'm not using like this. Okay, so I'll remove all these things. Okay, I use only these many disks. Okay, then what is my total storage per single node? Okay, it is 22 TB. Okay, so here, okay, you can put 1 TB hard disk. Okay, so based on the slot, okay, support. Okay, so you can put 1 TB, 2 TB, 4 TB, 6 TB, like this you can put. Okay, so think that, okay, so these are also in use. Okay, okay, and one more thing is, okay, is it having, okay, so what is better in Hadoop? Having 1 TB disk are better. 1 TB disk are better. Okay, 1 10 TB disk is better. Both are same, right? 10 1 TBs and 1 10 TB. Both are same or not?
Yes, sir.
Both are same. Okay. This
But
also.
sir, 1 TB is better in terms of performances because
Which one is better? Which one is first one or second one?
first one, sir.
First one, sir.
Why first one?
Sir,
Second one,
because while writing or retrieving data, yeah.
See, if you have single hard disk, okay, suppose, okay, if you have single hard disk, okay, this hard disk can write and read and write with the speed of, say, 10 MB per second. I'm just doing example, 10 MB per second. Okay, but here I have 10 1 TBs. Okay, each disk, okay, will write, okay, with 100 MB per second. I have only one hard disk. Okay, this will go with the speed of 10 MB per second. But okay, here I have 10 hard disks. Each one is writing with, okay, 150 Mbps. Okay, 150 per second. Okay. So now, who will write fast? 10 into 50 MB per second. Okay, it means, okay, this is writing with the speed of, okay, 1500 MB per second. Okay, this is writing with the speed of 300 MB per second. Okay, which one is faster? Tell me now. Obviously, having multiple hard disk only better. Okay, rather than single hard disk. Okay, so Hadoop suggests, okay, have multiple hard disk. Okay, not okay. So try to have multiple hard disk. Okay, if you want 10 TB, better to have, okay, 10 1 TBs. Okay, or okay, 5 2 TBs than 1 10 TB. That's what Hadoop is suggesting. Okay, so here, okay, you can go for 1 TB, 1 TB, or okay, you can go for, okay, 2 TB. Okay, you can go for 2 TB. And okay, and again, okay, how many can be used? Okay, that is purely based on us, right? Is there any rule that, okay, everything should be used in a laptop? If you have 26 slots, okay, is there any rule that, okay, everything should be used? Huh? No. Okay, there is no rule. Okay, so now you decide, okay, how many disks you want to use, okay, in each machine. Okay, let's say I used, okay, so how many I used? Okay, so 10 I used. Okay, The remaining, okay, I will put call 4 TB disks. Okay. So I'll put okay one more also. Okay. So now if you say okay, so total, okay, what is the total storage in one server now? Altogether, if I sum all the hard disk in this server, okay, how much storage I'm getting?
80.
80 TB, sir.
Okay? It means okay, if you order these servers, okay, now okay, if you tell, okay, if you order these servers, okay, like hey vendors, okay, so your vendors may be Dell, Cisco, okay, IBM, these are the vendors, okay. So now if you tell vendors, okay, hey vendors, okay, I want okay, a server, okay, with 80 TB capacity, okay. So this is my requirement, okay. So fill all the disk, okay. How many disk, okay? Fill out of 26 disk, okay. Put all 24 disk, okay. So all 24 disk should be okay of the size 80 TB, okay. So it means okay, if you go with okay, if one data node, one single data node is having 80 TB storage, okay. So when I say Hadoop cluster, okay, when I say HDFS, okay, it will be in data nodes or okay, only name nodes. When I say HDFS, okay, will it be in data node? HDFS will be a storage.
Both name nodes and data.
Name node will have the metadata. Actual data will be in HDFS, right?
Yes,
So
sir.
it means okay, so this is a single data node, okay. If I go with single data node, okay, so how many data nodes are required here, guys? Huh? How many data nodes are required?
Can we say 68?
So, 68.
If you are going with 1 terabyte of storage to achieve full parallelism, maybe 68.
Okay. So it means okay. So for total of okay to cover okay, this 5,421 TB storage, I need okay 68 data nodes total. Okay, I need 68 data nodes. Apart from this one, okay, I need some master nodes also, right? What do you mean of master nodes? So these are the nodes okay, where I install my
Name node.
okay, resource manager, HBase master, okay, and okay, so what servers I want, okay, keep us all those things. Okay. So all together, okay, you may require, okay.
So why we are calculating master nodes as separate? Edge node is okay because it is separate cluster. It means it is not counted in HDFS. But for master also, okay, yeah, because masters also anyhow it won't be considered.
Yeah, so masters are not required.
Yes, sir. Yeah, it is not considered. Yes, got it.
Masters are required, right?
Yes.
Okay. So here, okay. So now what we are doing, okay, here, okay, we are keeping okay 5 master nodes. So normally, okay, when they are building a production cluster, they at least keep okay 5 nodes. Okay, they will not go with okay 3 zookeepers. Okay, so they'll go with the 5 zookeepers. So they put 5 master nodes. Okay, so master nodes means okay, these are the nodes where you install your master services like name node, resource manager, all those things. Okay, so now I require 5 master nodes, and okay, how many edge nodes are required? See, number of edge nodes. Is there any rule for number of edge nodes? Normally, no. Okay, so but okay, so normally, okay, so number of edge nodes is purely depends on how many developers you have in your cluster, how many developers working on your Hadoop cluster. Okay, so here, okay, I've taken okay, so like okay, I've taken like 2 edge nodes. Okay, so now total servers required for Hadoop and edge node area equal to altogether how much? Altogether total servers required. Okay, so Hadoop and edge node area. So how many servers are required? Total 75 servers are required. Okay, it means okay. So what I'm talking, these 75 servers are nothing but these servers. This is the area I'm talking now. Okay, it means okay, this area should have 5 master nodes. Okay, Okay, this area should have 5 master nodes. Okay, and okay, 68 worker nodes. So 68 data nodes, worker nodes. Okay, and okay, 2 edge nodes. Okay, I'm talking about this area, guys. I'm talking about this area. This area plus this area. Understood? Understood? Or any questions?
Understood.
Okay, this is the area where I'm talking about. This one plus, okay. Okay, one more to put this one. This area plus this area. These two together, okay. That means okay, we planned for this area plus this area, okay. These two together, okay. This is what okay we require. Total 75 servers, okay. Of size, what size? 75 servers of this size.
Each 80 TB.
80 TB, okay. Okay, so otherwise, okay, so we'll give separate configuration for worker node. This is worker node. Okay. So in the same way, we will give for master node also. Master node. Okay. But do you think okay, master node we require this much TB? Master node will be maintaining only the metadata, right? Huh? So
Yes, sir.
you may not use okay, you may not be using these many hard disks, okay, in this one. So maybe you are using okay around 32 TB. Around 32 TB. Okay, so 5 disks you are using. That's it. Okay, so OS disk and okay, and here you are using and OS also you will go with 2 TB, 2 TB. Okay, the remaining is 4 TB, 4 TB. So all together, okay. So what is the server size? Okay, master node server size. This is the master node capacity. Okay, so you are okay. You are ordering worker node separately, master node separately because master node doesn't require more storage. Okay, because they store only metadata. For metadata, they don't require more and more storage. You can still reduce actually. Okay, or you can go 4 TB, 4 TB. This is fine. Okay, so but
These values just we are assuming, sir.
not assuming, sir. Okay, we are just keeping it. Sir, okay, so here in this master node, okay, we are filling only out of 26 slots, we are filling only 6 slots. First 2 slots, okay, we'll be installing OS, okay, and remaining 4 slots, okay, maybe in this slot, okay, I will use okay, this slot, okay, I use for FS image. This slot I'll use for okay, edit log. This slot I'll use for okay, journal edits. Okay, Jetkit Zookeeper data. Okay, HBase master data. Okay, so like this I'll be using this hard disk.
Okay, so that is fine. So that's 4 terabyte. Just we
you're
are,
assuming. Yes,
assuming.
Yes, yes.
Okay.
Okay. So now altogether, how many servers we want? So to build this cluster, I need okay 75 servers. Okay, so 68 data master data nodes and 5 master nodes and 2 edge nodes. Okay, so this is my total capacity. Will you agree with me? Huh? Will you agree with me?
Yes,
Guys?
sir. Yes, sir.
Yes.
I'll put this one first.
Yeah, number of data nodes might be little bit small maybe. We are having 80 terabytes in one data node, right?
Right.
Having 68 might be a lot.
Got, huh? Okay, this is the calculation, sir. 5421 TB. Okay, so what is your this one total storage? 5421. 5421 divided by
Yeah,
divided by
that itself will be more than 5040 something like that.
68, sir.
5440.
correct only, na?
Oh, correct. Okay.
See, this is total storage, right? This divided by 80. 68 nodes. Correct only.
Okay, sir.
The formula I put, sir. This is the formula. It will auto calculate. Okay. So now, okay, you have these many worker nodes. Okay, instead of data nodes, I will say these many worker nodes. Workers, okay. Okay. So total worker nodes required 68. Okay, master nodes required 5. Okay, edge nodes required 2. Okay, so total 75 servers are required. Okay, this is to cover what? This is to cover only these 2 areas. Will you agree with me? But I can have other areas also, right? Other areas also, correct or not? Okay. So now other areas, okay, you need to ask them, okay, whether they want to use Kafka, okay, they want to use NiFi, they want to use Storm. Some people will say, I don't want Storm, or some people may say, okay, I don't have NiFi use case, okay, I don't want, okay, ELK. So there is no a rule that everybody should okay, when I say Hadoop cluster, everybody should use all the tools. There is no rule. Okay. So okay, so here, so what I will put, so UI node also put 1. Okay. So normally UI will be installed. Okay, so so I will put UI node also 1. Okay. Okay. So total 26. Okay, it means UI node also covered here. Okay. Even this also covered here. Or not? Even this also covered. Okay. So it means okay, this entire area I covered now in the planning. This is total 76 servers are required. Okay. Okay. So normally, okay, so okay. 2040 we also more. Potentially. Okay. So let's talk about okay. So now what is the capacity of this one? Okay. So here okay. So now so
Sir.
Sir.
Sir, అది డేటా నోట్ 80 టెరాబైట్ ఒకసారి చెప్తారు సార్, అది ఎలా తీసుకుంటాం? One second, sir. Worker nodes. Okay.
So usually for Spark, we will have separate cluster or the existing cluster only they'll be using.
1 second.
Yeah, sure.
Okay. Okay, sir. Okay, so now let's talk about this one. Okay, so now, okay. Okay.
Hello.
You're asking about data node, worker node, right?
Yeah, worker node, sir. 80 terabyte అనేది ఒకసారి చెప్పండి సార్.
Sir, okay, you know that, okay, how many, okay, do you know how many hard disks, okay, we can keep in one hard disk, one server? How many hard disks we can keep in one server?
Maximum 26.
26 hard disk, okay? So now, okay, 26 slots will be there, okay, you can keep 26 hard disk, but okay, it is up to you, right, how many slots you will use? It is up to you.
We don't know, sir. Yes, sir. Based on the data.
Okay. So based on the requirement, okay, you use. Understand?
Yes.
Okay.
Okay.
So now what I'm doing, okay, so out of 26 slots, okay, I'm using only 24 slots. I'm not using last two slots.
Okay.
Okay. So 22 slots, okay, I'm using. Okay. And is there any rule that okay, every slot should be of same size?
No, sir. Not like that.
No. Okay, sir. Okay, you have 2 RAM slots in your laptop, sir. Okay, in one slot you can put 8 GB RAM, and okay, other slot you can put okay 4 GB RAM, right?
Yes.
So total,
yes,
how much
sir.
it will become?
12 GB RAM.
12 GB RAM.
8 plus
Yes,
4.
sir.
Right?
8 plus 4. Okay, but okay, if you put only 1 8, will it work or not?
Yes.
It will work, right?
Yeah.
Yes, right. Okay, so in the
Yes,
same way
yes,
here
sir.
also. So
Yes, sir.
here also, it is up to you whether you insert the, okay, you add a hard disk to in each slot or not. Okay, but
Yes,
here,
yes.
okay, what we did, okay, so we did like this. Okay, for OS disk, okay, this is what we used. Okay, for other disk, okay, we used okay 2 TB till here, and okay, we used 4 TB here. Okay, total altogether it has become 80 TB now. Understood?
Okay, these values are assuming, sir, just
normally
4 TB, 2 TB.
yes, sir. Okay, yes, sir. 4 TB to be is taken at them.
Okay, okay. I think is there any
Here itself,
formula based on the total size, data size, we require like that, I think.
These are assumptions, sir. Yes.
Okay, sir. Fine, sir.
Okay. So 80 TB per node. Okay, so in this case, okay, so total worker nodes required is
based on the 80 TB, we divided by
total request storage, total disk. Okay, 68 data nodes.
Okay, sir.
Okay.
Got it.
Okay, then okay, 5 master nodes. These are okay mandatory. Even for small cluster or big cluster, 5 master nodes are mandatory. Okay, 2 edge nodes.
So for the master node, what is the space required? Mandatory? Anything idea?
I'll tell, sir. I'll tell about that. Okay. So edge nodes. Okay, 2 edge nodes. Okay. So but okay. So there can be more edge nodes also, less edge nodes also. Okay. So this is purely based on number of developers.
Developers.
Okay. So one UI node. Okay. Normally in real time, okay, the UI node will be part of any one of the master. UI node, okay. UI also will be installed on any one of the master node in real time. But okay, let's say anyway, okay, for this, okay, I'm adding one extra node. Okay, so total altogether how many? 76 nodes altogether. Okay, so it means okay, so to build okay your cluster, okay, so to store all your 1012 TB data, I require now 76 servers. Okay, this is to cover only this area, these 3 areas. Okay, but here we have other areas also. Okay, so now what is the normal capacity? Usually when I say worker node, okay, you will have more storage and okay, usually less RAM or cores. Okay, usually I'm saying. Okay, so that is the reason. Okay, so we are ordering worker nodes like this actually. Okay, 68 servers of each size. Okay, 80 TB storage, 32 cores, and 256 GB RAM. This is the capacity of my worker node. Okay, but when it comes to master node, okay, master node, okay, will store only the metadata, but it requires this metadata to be stored in RAM also. Okay, that is the reason for master nodes. Okay, your request storage is less. Okay, but when it comes to RAM, you require more and more RAM here. So here I'm using 512 GB RAM. Understood? Okay. And when it comes to Edge node. Okay, edge node.
Generally, this is the configuration for RAM we are doing, or we can vary. Means it can vary. RAM specific.
Sorry?
For RAM,
This is
we'll
the general, sir. This is the general configuration, sir. Okay, sir. Normally, when you are planning for a house, okay, you are planning for a house. Okay. Normally, what they say, sir. Okay, the default size of the master bedroom is 12 by. This is the default size of master bedroom. They say. Okay, and this is the default size of other bedroom. These are the default sizes as far I know. Okay, 12 by 10. Okay, and 10 by 10. These are the both bedrooms sizes actually, measurements. Okay, but do you think people will go with size only? Do you think
No, sir. Based
Ambani
on
house also
space.
same size of bedroom they have?
it can vary, sir. Yes.
It will vary. Okay, but I'm giving just okay default values I'm giving. So here when I say okay, name node, okay, they use 512 GB. This is in the current days. Okay, if anybody is setting up, okay, this is the minimum requirement they use. They go. Got it.
Sir, one general question. Sir, see here we are using same, means generally for Spark also we will be using same cluster, like
Okay.
and yeah, kind of I want to ask like, is there any separate
For
cluster?
Spark,
for all?
okay, you may use okay more. Okay,
sir.
Storm, okay, more. Okay, see here. Okay, so these are the requirement for others. See here.
Okay, sir.
I'm talking about those also. First, okay, let's talk about worker nodes, then master nodes, then edge nodes. Okay, worker nodes. Okay, normally they require more storage, and okay, so usually less RAM or cores. Okay, but when it comes to master nodes, okay, they require less storage and more cores and more RAM. Okay, so that is the reason. Okay, storage is only 14 TB, but here okay, worker node storage is 80 TB, but master node storage is only 14 TB and 512 GB RAM. Okay. But edge nodes, normal edge nodes require more storage and more RAM. Okay, you know why? You know why? Because okay, so this is the place where more developers, okay, the traffic will be there. More developers will be logged into this one, and okay, and again, the developers will be using this edge nodes like a staging areas to copy their data into Hadoop. Okay, that is the reason. That is the reason. Okay, we require more storage and more RAM. Okay,
but prod servers will not be using, means will not be used by developers. Yes, like
which one,
kind
sir?
of prod servers will not be used by developers. Yes, in that case we can keep it a little less. Yes, for production servers as node.
Prod edge nodes, yes sir, yes sir. Okay, prod edge nodes, okay, yes, okay, you can give less sizes. Okay,
Got it.
Yeah. Okay, so this is what okay we are selecting. These are the node capacities we are selecting for Hadoop area. Okay, but okay, apart from that, okay, we have okay Kafka area here. Okay, so we have Kafka area. Okay, we have Kafka area. We have NiFi area. Okay, we have Storm area. We have Spark area. Okay, okay. So Spark area. Okay, we have ELK area, Trino area, okay, security area. So what I'm doing, okay, so these are okay, so minimum, okay, Spark cluster they'll have. Okay, Storm, okay, I'm not sure. Okay, so here, okay, so Kafka, NiFi, Spark, these are mandatory in anything. Okay, so nowadays, okay, security. Okay, so okay, the security area mandatory, okay, and others. Okay, so others. Okay, so all together, okay, I'm keeping these many, sir. Okay, so how many servers okay we are keeping here? Okay, so here, okay, so total 76 plus 76 plus
34.
34.
34. Okay, total 110 servers so we require. Overall servers required, okay, to set up this cluster is if I buy 110 servers of these sizes and all. Okay, so it is a perfect cluster for me. Okay, to start with. Understand?
Sir, we can say 110 node cluster.
Yes, now I will say this is a 110 node cluster.
Okay.
Understand? Okay, now I will say I have 110 node cluster. Okay, just imagine if I say I have 2000 node cluster. Just imagine. 2000 nodes cluster. Okay. But end of the day, 100 node cluster, 10 node cluster, 100 node cluster, 10,000 node cluster. Okay, all are same. Only thing is that only thing number of nodes are increasing. Yes or no?
Yes, sir. Number of data nodes and
Number of data nodes. Mostly number of worker nodes will increase, sir.
yes, sir.
Understand? These are the ones mostly which will increase on continuous basis, because so finally the data will come and sit in the worker
Data
nodes.
will be increasing day by day, right? So that's
Yes. So understood, guys. Okay, so now
As a node requirement, how much like how much logins one edge node can handle, kind of?
sir, it depends on server capacity, right?
Okay, sir.
Understand?
Got it, sir. Yes.
So see, they put a edge node with let's say 8 cores, plus 64 GB RAM. Okay, how many it can man? So is there a difference between 80 this server and this server? This is a 64 GB RAM. Okay, now tell me. Okay, one server. Okay, so server is not same, right? Yeah.
Yes, sir.
So it means I cannot. If you answer sir, one server means I cannot answer you. It is purely based on
general configuration, whatever we defined for that one. How much will it be able to handle?
Sorry.
Sir, for general configuration, whatever we took for edge node now, that much means that one, this server, how much will it handle?
100 TB storage, 512 GB RAM and all. Huh?
Yes,
okay.
Sir. Yes,
sir. See here, rather than saying number of this one, suppose I agree with you. Suppose there are only 2 people logging into these edge nodes. Okay, they are running 1,000 jobs from here. What will happen, sir?
Yeah, 2,000 directly means 1,000.
All these 1,000 jobs will be using 512 GB RAM. Okay, if third person login, he will not have anything to work.
Correct. Got it, sir. Yes.
So it's based on number of so don't worry how many people it will allow, how many sessions it will allow and all. Rather than that, how much load you are putting on that.
Load.
That is the thing.
Got it. Yes, sir.
Okay. So guys, I hope you got an idea. Okay, so I hope you got an idea. Like so what is the real? So how the real-time cluster will be planned and all. So this is not for less experienced people. This is mostly for the people who are trying for architect positions.
a small doubt, sir.
Yes, sir. Tell me.
If you increase suddenly for the 50 data nodes, it will affect for all the other edge nodes and any configuration will change, sir.
Why it will? Why it will, sir?
The data size will be more, sir. So that's why any.
If you suddenly if your data is growing, so you will increase the number of worker nodes. Okay. If you increase number of worker nodes, data will be rebalanced, right?
The data will be rebalanced, sir. So no effect for okay.
So since you are increasing the number of worker nodes, you may not increase these nodes, right?
No, sir.
So see, is number of LDAPs is based on how many worker nodes you have here. If worker nodes are increasing, number of LDAPs will increase. Even though I have 100 worker nodes, 200 worker nodes, my LDAP will be same.
Only actual data will be.
Yes. Okay. When I say cluster is growing, what is growing? Number of nodes. Okay. Size of the data is growing. Data volume is growing. Since data volume is growing, you are adding more and more nodes. Whenever you feel that the free space is less than 30%, you will start adding this one. Adding new data nodes.
Yes, sir.
Clear? Okay.
Got it, sir.
So this is how So if you change this actual data copy, let's say if you put let's say you have 5,000 TB data. Okay. So number of years data. So shall I add that one also here? Number of years. Let's say from last 50 years. Let's say so from last 52 years. Okay, from last 52 years, okay, it is increasing. It is running. So on average data growth per month. Monthly. It's equal to this divided by this divided by 24. Okay. So from last 50 years, okay, your business is like this. From last 52 years, okay, so okay. From last 52 years, okay, your business is like this. Okay, in last 52 years, okay, your total data has become 5000 TB. Okay, so it means, okay, if I go in this calculation, okay, so on average monthly 8 TB is coming. Okay, so it means 5048. Okay, so if I go this one, I require, what is the total size of the cluster I require? So to set up the cluster, okay, which match this requirement, okay, so I require 381 servers. Understood? Okay, so I hope, okay, you got an idea now. What is this? Huh? Okay.
Sir, real time lo zookeeper servers separate ga maintain chestharu.
Which one?
Zookeeper.
Zookeepers will go on master nodes, right?
Okay. Real time lo alage untada.
Real time lo kuda. Yes. Even in real time, okay, they maintain the zookeepers on separate server, on master nodes only. Okay. So guys, now, okay, so now, okay, when you go to any interview, so they will ask, okay, how many clusters you have? First question, okay. So there will be some mandatory questions in the interview, guys, in Hadoop interview, okay. How many clusters you have? Okay. So when I say how many clusters, okay, so here, okay, the minimum number of clusters are these many. Okay. These are the minimum number of clusters. Okay. How many? 4 clusters. Okay. One is test cluster. Why test cluster? What is the use of this test cluster, guys? What is the use of this test cluster?
For
testing purpose, sir.
POC.
What is the use of this test cluster? Normally,
mostly for admins. Mostly for admins.
So to do, okay, R&D on new installations, okay, upgrades, okay, new installations, upgrades, okay, so patching, okay, etc. Okay, so suddenly, okay, your manager asks you to install, so upgrade your cluster. Okay, which cluster you will upgrade? If you upgrade development, okay, other clusters, okay, if they are okay, if they got corrected, okay, it's a problem. Okay, so if it's a test cluster, even if you lost the test cluster, also no problem. Okay, you can recreate the test cluster again. You can take 6 nodes and you can recreate the clusters. Okay, so normally test clusters will be used by Hadoop admins. Used by Hadoop admins, okay, to do R&D, new installations, upgrades, patching, okay, anything. Okay, new installations. Okay, so config changes. Installations updates matching.
R&D.
R&D means okay, research and development.
Okay.
Okay. So normally when okay, there is something new you want to install it, you will install. You will try that in the test cluster. Even though you lost the test cluster, no problem. Okay. So used by Hadoop admins only. Okay. So who will use the development cluster? Okay. So used by Hadoop developers to develop code. Okay. Code or jobs. Write code, jobs, or applications. Okay. So normally who will use this cluster? So the developer cluster is used by Hadoop developers mostly here. To write okay, new codes, to write okay, to develop only. Develop new code, okay, new applications, and test the functionality of the same.
Sir, here we have mentioned the storage. Storage is
okay, we'll come to there, sir. We'll come to there after. Okay. First, let us try to understand. Okay, who will do what? Okay. So mostly this development cluster will be used by Hadoop developers. Okay. So mostly to develop. Okay. Mostly to develop new codes or jobs or applications and test the functionality of the same. Functionality means okay. So now okay, they write okay on the same on small data of the same on the small data. Okay. So now okay, in the development cluster, let's say I'm writing a query. Okay. So I want to run a report, sir. Okay. So first, what I will do, I'll write a query. Okay, in the development cluster. Okay. I'll write a query and okay, I will run this on okay. Also,
it is under Edge Node
1 GB data. Let's say 1 GB, 2 GB data. We'll check whether the query is working fine or not. Okay. So let's say it is working fine. Then what I will do? I'll copy the same code into UAT cluster. Okay. So normally when it comes to UAT cluster, used by Hadoop developers mostly to test to deploy code. Okay. Code developed in dev cluster and test the functionality of the same on the okay, for functionality and performance. Same on huge data. Okay. So normally for what purpose okay, they'll use a UAT cluster. UAT cluster means okay. So this is the place okay, where they develop the code and they do the functionality test. Okay. So they test okay, small data in GBs. Okay. So they write a query, they develop a query. Okay, let's 100-line query they develop and they run this query on 1 GB data, 2 GB data. Okay. If it is working fine, then they'll copy the same code into UAT cluster and okay, they run the same job okay on TBs of data. Let's say so they are running the same code okay, on 10 petabyte 10 TBs of data. Okay, 10 TB data. When I say 10 TB of data, so mostly when you are running on 10 TB data, maybe your query is running fast when you are running on 1 GB data, but okay, your query is running slow when you are running the same on 1 TB data. Okay, 10 TB data. Okay, maybe your query is running fine when you are running on 1 GB data, okay, but your query is failing when you are running on 10 TB's data, maybe. So some memory settings, okay, you need to do. Okay, so what they will do the functionality test and performance test both. Okay, both in this one. Okay, if everything is fine. Okay, so mostly to deploy the code developed. So whatever code developed here, they deploy the code in the deploy means copy the code into UAT cluster and okay, test the functionality and performance of the same, okay, on huge data. Okay, so if there's any issues, okay, again, okay, they will deploy it, they will make the changes in development cluster, again deploy it in the UAT cluster. Okay, when it comes to production cluster, okay, what they do, okay, so mostly used by Hadoop admins, mostly, okay, to deploy the code developed and tested by developers. In both, okay, the one UAT clusters, okay, and monitor the same. What do you mean of this one? So we have access to production cluster, guys. So do you think all admins will have developers will have access to production cluster? So developers are the one, they develop the code here and they do functionality test, and then okay, they bring the same code to UAT, and okay, here okay, they will do the performance test. Okay, so if functionality test and performance test everything is working fine, okay, then okay, so developers will ask admin teams, okay, hey admins, okay, so we don't have access to production cluster, so can you please okay deploy our code, can you please copy our code into production and start the job. So as a Hadoop admin, okay, it is your responsibility to submit a job, okay, deploy a job, okay, the code, okay, developed and tested by Hadoop developers in okay clusters and monitor the same. Deploy the code in production cluster and monitor the same. Understood? So now what is the work of this one? Used by Hadoop admins, okay, mostly. Okay. In some companies, okay, so even developers also will have access case. Okay. Some companies, okay, only admins will have access. Okay. So deployment means okay, so just copying the code. Copying the code from one place to other place. Okay, that is called deployment. Okay, so but most of the companies, okay, so none of the production people will be having access to production cluster. Okay, so or even if they have also, okay, even if developers understood. Hadoop developers okay, will or may have, okay, will have, so we have read-only access to production jobs, okay, to check, not to test, okay, to check in case of any failures. Okay. So here, okay, so they write a program in such a way that okay, if any job is failed in production, okay, so the same code is failed in production, okay, they will get a mail. Okay, Hadoop admin will come to another, okay, there is a failure in this cluster, okay, in this job. So immediately, so he will see who is the owner of the job, and okay, he will inform that person. Okay, so that person, okay, will have okay, read-only access on the jobs. Okay, so he will using that read-only access. Okay, he or she will just log into this cluster and okay, check okay why the production job got failed. What is the reason? Okay, so if they know what is the reason, then okay, again they'll go back to development cluster. They'll fix the issue. Then they'll do the functionality test here. Then they'll put it here and they'll performance test. Then okay, they'll ask admins to deploy the new code again in the production. Okay, so that okay, it will run fine now. Understood? Okay, so I hope okay you got okay an idea like okay who will have access to what. Okay, and the last one is DR cluster. So this is the DR cluster. Okay, so normally DR cluster. Okay. So okay, used by Hadoop developers. Sorry, Hadoop admins only. Okay, used by Hadoop admins mostly to set up the backup jobs. Set up the data backup jobs. Okay. From prod to DR. Understood? Okay. So yes, some people will use this one. So some people may not have DR cluster separately. They will use UAT cluster as a DR cluster. Some people, okay, but some people will have separate DR cluster. So you will not have okay, these many nodes. Okay, let's say maybe okay, and okay, so 100 nodes. Okay, so here. Okay, so guys, okay, so definitely when you are giving an interview, they'll ask how many clusters you have, what is the cluster size. Okay, so UAT means user acceptance test. Okay, cluster UAT means okay. So here, okay, so test cluster, development cluster. Okay, at least okay, you need to talk about these environments. Okay, different clusters. Okay, understand? Okay, and one more thing, guys. Okay, suppose okay, let's say okay, I'm talking about a bank. Okay, XYZ bank. Okay, this XYZ bank has 5 different sections. XYZ bank. Okay, so they have okay credit cards. Okay, so they have a account section. Okay. Accounts, they have credit card, they have loans, they have insurance. So these are the different like LOBs okay, we have for this bank. Okay, for this bank. Okay, suppose okay, if they feel that okay, so no, okay, I don't want a single cluster to store all my data. Okay, so normally what you can do, you can have okay all the data in one place. Okay, that is Hadoop policy. Okay. But now, okay, these people decided that okay, no, I will have separate cluster for account. Okay, so then okay, you will have separate dev. So okay, for every account section, okay, you will have separate test cluster, separate dev cluster, separate UAT cluster, separate okay production cluster. Okay, maybe separate okay DR cluster. Okay. So now like this, okay, so we have understood. Every department may have separate. Okay. But what in case, okay, if they are all storing everything in the same place? It is one way, okay. But okay, so but okay, this bank decided to store everything in one place. Okay, so then okay, we'll have cluster. So if they tell that okay, no, I want okay, account section wants a separate cluster, credit card section wants separate cluster, loan section wants separate cluster, insurance section wants separate cluster. Okay, then okay, every section will have all these 4 setups. Okay, but okay, if they go with okay everything in one place, then okay, we'll have only one cluster, one test cluster for entire XYZ bank, one dev cluster for entire XYZ bank, one UAT cluster for entire XYZ bank. Okay, like this. Okay, so now, okay, if I say that okay, we have 35 clusters, what does it mean? 35 Hadoop clusters. So if you see here, all these together itself, okay, how many is the clusters? Okay, we have 16 Hadoop clusters. Correct or not? Huh?
Yes, sir.
So like this, okay, so maybe when I say 35 clusters, okay, these will have different what to say line of businesses, okay, and each line of business have different clusters. So all together, okay, I'm saying I have 35 clusters. Understood? Or any questions? Okay, so now they'll ask, okay, so definitely in interview, one of the questions is how many clusters you have, okay? What is the capacity of each cluster? Okay. Minimum you need to tell. Okay. I say normally when they're asking what is the capacity of each cluster, okay, they'll ask for production cluster, okay, or UAT cluster. They'll not ask about how many test nodes you have and all, okay? But okay, so instead of telling, okay, some big numbers, okay, so don't tell big numbers, okay? So, okay, if you tell big numbers, okay, you may not be able to handle it properly. So dev cluster, okay, you tell, okay, we have only 6 nodes, okay, and maximum data size of data we process in test, okay, maximum storage we have is 30 TB, okay, and okay, dev cluster, okay, you tell, okay, we have 30 to 40 nodes, around 200 TB storage altogether. UAT cluster, okay, we have, okay, 80 to 150 nodes UAT cluster. If DR is included, okay, you tell 150 nodes, okay, but if you say only UAT, then tell 80 nodes, okay, 1000 TB storage, okay, production cluster, okay, you tell 150 to 300 nodes. You can tell any number, okay, 150 also you tell, okay, 200 also you tell. So, but if they ask, like, what is the average data we have here, okay, 1000, okay, what is the total storage here? This is not data, guys, okay, 1500 TB, okay. So these are the best number to start with, okay. If anybody asks in the interview, what is your cluster size, you can tell like this, okay. So here, okay, what I have given, okay. So here, okay, for each cluster, okay, I have given, okay. So for dev cluster, what is single copy of data with replication, okay. Total HDFS, what is overall cluster capacity, okay. So how many nodes we have in the Hadoop area, how many are in the Kafka area, Spark area. So like this, okay, I have given one real numbers case. Real numbers I have given, okay. UAT cluster 3.2 petabyte storage, okay. Production cluster 6.4 petabyte, okay. So you take a printout of this one and you explain same thing. So you tell that, okay, in our production cluster we have 177 nodes, okay. If they ask how many master nodes, tell 5 master nodes. What is the capacity, okay, tell 8 TB, 32 cores, 512 GB. How many worker nodes we have? This many. How many edge nodes we have, okay. So if they ask like this, okay, you tell like this. Understood? Understood, guys? Okay. So this will give you complete okay, picture, like, okay, tomorrow, okay, definitely people will have a doubt, like, sir, how many nodes I should tell. So this is the one, okay, I have given, okay. If they ask also what is your actual data single copy, you can tell 1.2 petabyte, okay, with replication 3.6 petabyte, total HDFS 5.1 petabyte, overall cluster capacity 6.4 petabyte. So how many nodes you have? 177 nodes, okay. So like this, okay, you keep this in okay, you keep this, okay, ready with you when you're attending interview, okay. Clear, guys? Okay, you keep this ready with you, okay. So this will give you complete picture, okay. So there are some companies, okay, where they will test you, okay, whether you are real time or not based on this one. Supposing if I am really working in Hadoop, okay, will I be knowing all these things or not, guys? Daily you are working on the cluster, okay. Don't you know how many nodes you have on the cluster? What is the storage of the cluster? Okay. What is the HDFS capacity? What is the OS capacity? Okay. So everything you will be knowing, right? Yes or no? If you are really working. So you should be ready with all these numbers, guys. And okay, this is the
like 4 type of clusters we are using, like that you can say.
Not type of cluster, sir. Okay, you cannot say type of cluster. Is it a type of cluster?
Not type, sir. We have 4 clusters, like.
You tell we have 4 clusters. That's it. Okay. So this is the thing actually. This is the master nodes. Okay. These are the edge. Okay. This is the edge nodes. This is the UI area. These are the other areas. Okay. Security area. Everything. Understood?
So generally this database thing, HBase or any other NoSQL database, admin only will be managing, and issues related to that
What do you mean of admin
Hadoop
only managing?
admin will only, because database is separate team, yes, most of the time, sir. So just I had a query, I thought asking. Sir, like if any, see, we are using Cassandra kind, okay, database and HBase also.
Okay.
So, sir, yeah.
Yes, sir. See, this can be, you can say, all together. Okay. Normally, people will not go in that much in depth. Okay. But okay, this will cover everything. Even if you go for NoSQL database, anything, okay, you go, okay, this will cover everything.
Okay, sir. Okay. Got it.
Sir, even though it is a NoSQL data or okay, SQL data or Hive data, any data, and now when it is coming to STFS, it is data. Yes or no? Yes or no?
Yes, sir. Yes, sir.
Yeah. Then what is the problem? No problem,
Okay,
right?
sir. Yeah, got it.
Sir, what is the Hadoop migration engineer profile, sir?
Sorry?
Hadoop migration engineer profile, sir.
Okay, Hadoop migration engineer. Huh? Okay, so maybe I'll cover in the later stages, sir. Okay.
Okay, sir. I want to know that what it does. Is it part of Hadoop admin or something else, sir?
Of course, yes, right. Okay, so even Hadoop admin will be there. Even Hadoop developers also will be there in the migration part.
Okay, okay, sir.
Okay. Okay, so okay, this is the updated one. Okay, so I'll upload it to Drive right now because this is a bit important. Okay, so fine, guys. Okay, so now so we understood the cluster planning. Okay, what next? What next? Okay, so we'll go to the theory part. Okay, cluster planning. Okay, so here CPU. Okay, the more CPUs means okay, more resources. Yes or no? Huh? The more CPUs means okay, more resources. Okay, CPU intensive jobs may require more cores. Okay, what do you mean of CPU intensive jobs? That's you are running some okay machine learning algorithms. This requires more CPU. Okay, so if you require more CPU, it means okay, you require more cores. So preferably we can have okay, 24 cores per development cluster, 32 cores per UAT cluster, 30 or 40 cores or above for production cluster. Okay, so normally when you are building a Hadoop cluster, okay, so will you select okay, all the high-end servers okay, for UAT cluster, production cluster, and dev cluster? No. Okay, so normally for dev clusters, okay, they will go with the okay small size small capacity servers. You will go with okay 16 cores or 12 cores like that. Okay, so for UAT 32 cores, okay, for production 40 and above. Okay, so in our production cluster we are using 80 core servers at this moment. 80 cores, 1 TB RAM we are using. Okay, so that is about CPU. And okay, when it comes to RAM, okay, even RAM also. Okay, so for okay, you require more and more RAM for master nodes. Okay, and maybe less RAM for worker nodes. Okay, so because okay, why you require more RAM for master nodes? Master nodes are the ones who will be maintaining the metadata. So to store all the metadata in one place, again RAM, okay, we require more and more RAM. But okay, when it comes to data nodes or node managers, okay, these resources will be, this RAM will be used only for job execution. Okay, of course, okay, if you have more RAM here also, it's good to launch more resources, more mapper JVMs or reducer JVMs, okay, or more executors or more containers. But okay, but it is okay. Okay, but definitely data worker nodes are not expecting more RAM, okay, like name nodes, like master nodes.
Okay, sir.
Okay.
Sir,
To,
this core we are talking. We have just now talked about core. So we are talking in terms of cluster. Cluster itself is having. Can you go the last screen and the before? Yeah, this one. 24. Yeah. So
this is per server, sir. Per server, sir.
Okay, per server. Yes, sir. Okay, so okay. I thought
per server.
Okay. Yeah.
Not per cluster.
Yeah, that would be very less. Yes. Okay, sir. Good.
Yeah. Okay. And okay, when it comes to hard disk, okay, it is better to have RAID disk for both OS and metadata disk. What is this RAID, guys? Don't give me abbreviation, it is already there. So normally, okay, so in RAID, okay, you have okay, striping and mirroring concept, right? They use okay mirroring concept. Mirroring means RAID 1. Okay. So, okay, if you don't know RAID, okay, don't worry guys. Okay, this will be taken care by Linux people. So they will take care of it. Okay. Don't worry about that. Okay. So normally, you know what they will do? They will keep, okay, 2 OS disk actually. Okay. So same copy of OS disk. If one OS disk is corrupted, okay, the system will still run with the second OS on the second disk. Okay. So that is the reason they keep two disks actually. Okay. And no RAID is required to store HDFS data as we have replication in place. Okay. So for HDFS disk, for other disk, okay, you don't require any RAID technology enabled. Okay. Because, okay, we have replication in place. So better to have more disk for data distribution. Okay. So as I explained earlier, okay, so it is better to have 10 1 TB disks, okay, rather than one 10 TB disk. Okay. For more data distribution and more I/O also. Okay. And need to have good RPM. Okay, that is 10,000 or above. Okay. So at least, okay, 10,000 or above. Okay. RPM you should have. RPM is rotation per minute. Okay. So the more RPM, okay, the more speed, okay, you can get from the disk. Okay. Then when it comes to network, okay, so it is better to have a dedicated VLAN. Okay, so it means, okay, instead of, okay, merging our Hadoop cluster with the other networks, okay, so better you have dedicated network for you. Okay, separate network for you. Okay, so and better to have more than one LAN or network interface card. What is network interface card is? Adapters. Okay, how many adapters we are taking in our practice VM? How many adapters we are taking? 2 adapters we are taking. Okay, so first one is, okay, NAT. Okay, other one is okay, host only adapter. Okay, but okay, in real time, okay, there may be different names for these adapters, but okay, but you will have at least 2 adapters even in real time also. Okay, and better to have 10 gig per second Ethernet cables. What is this 10 gig per second Ethernet cable? What is the capacity of our internet cable stage? You can download, okay, 2 MB, 3 MB, 10 MB max, 10 MB, 20 MB. Okay, based on the speed, internet speed, what you have. Correct or not? Okay, so maybe 100 MB per second. Okay, it's possible. Okay, but when it comes to the network cables, okay, what we are using for Hadoop cluster, okay, so for them, okay, if they transfer, okay, 100 MB per second, okay, almost they're required to transfer 1 TB data. That is the reason they use high-end Ethernet cables actually. 10 gig per second. When I say 10 gig per second, you can copy 14 movies in 1 second. Understand? On average, if the movie size is, okay, if one movie size is 600 MB or 700 MB, you can copy 14 movies in 1 second. Not one movie in 1 second, guys. 14 movies. So that is the kind of cables they use for the networking part. Okay. So this is a commonly used node configuration. So for development cluster, this is what you use. So you can tell, okay, you can start with 16 cores also, 24 cores or 32 cores. So when it comes to RAM development cluster RAM, you can in development cluster, one worker node can be 16 cores and 64 GB RAM also. Okay, or 24 cores, 128 GB RAM, 32 cores, 126 GB RAM. It depends on your requirement. Okay, if the client is poor, okay, not a rich client, then okay, you can suggest them that okay, to build development cluster, you go with 16 cores and 64 GB RAM, 10 servers, like this you can suggest. Okay.
So this is we are talking in terms of a single node, yes.
Single server.
Yeah, single server, yes. Okay, sir.
Single node configuration.
Okay, sir.
Okay, so on hard disk also, okay, for development cluster, okay, max you will go for 4 TB or 8 TB max. Okay, UAT cluster 8 TB or 16 TB, and production cluster it will be like, okay, 24 TB or more also. So in our cluster we are using 100 TB per server. So one server, all hard disk together, if a sum, okay, it will become 100 TB for us. Okay, and RAM also, okay, so 512 GB RAM or more. Okay, you can start with 128 GB or 256 GB, or you can go 512 GB or okay, more than that also. So as I told you, okay, we are using 100 TB storage plus 1 TB RAM and 80 cores. This is the servers. Okay, these are the recent servers what we purchased. 80 cores plus 1 TB RAM plus 100 TB storage. Okay, so And network cable, okay, for development cluster 1 gig per second is fine. Okay, but UAT test, okay, better to have 10 gig, but if you have 1 gig also fine. Okay, production cluster, you should have only 10 gig per second cable. It's mandatory. Okay, so this is the node configuration, and okay, now plan your cluster growth. Okay, this is what okay I've explained also. Okay, so
Sir, one moment, sir. So you said about this the space for the name node and all. You said later. So the size, yeah, you'll be telling it now, or
yeah, okay. Space for name node I've explained now, sir. What the size of name node and all explained, right?
You said 5 nodes, but standard. But
okay. And the size also I explained, right? 14 TB storage, 512 GB RAM.
Is it the standard, sir? What they are using?
This is the standard, sir. Okay, what people are using now. But if you want more, you can go. But okay, this is the standard they are using.
Okay, sir.
So these are all standards I'm telling. Okay, but this can vary. Okay, based on the money your client is having. Understand? So yes, even for production cluster, if you use if you build a production cluster using 8 core and 64 GB RAM, then it will work. Hadoop will not say I will not run. Okay, Hadoop will work, but okay, it will be slow. Very simple. Got it? But these are the standards. Okay, at this stage. Clear?
Yes, sir.
Okay. So now, so you understood, okay, what is cluster planning, okay? I've explained, okay, complete cluster planning also, I've explained, okay? So next, very interesting topic, okay. Okay. Okay, so guys, okay, so now we know that how to build a cluster, right? How to build a cluster, right? Now. Okay. So now, okay, think like this, guys. Okay, so this is XYZ Bank. Okay, and these are the 4 departments they have. Okay, maybe line of business or what you can say. Account section, credit card, loans, insurance. Okay, so they all okay. So accounts. Okay, this is current data plus next 6 months data. Credit card. Okay, so all together they have a okay 500 TB of data. I'm just giving example, guys. They have 500 TB of data. Okay, so now this is the cluster planning given by. This is the cluster planning given by Hadoop Architect to satisfy the requirements of 500 TB, okay, of data. Understand? Okay, this is the plan. Okay, he clearly told that. Okay, so overall servers required are 100 servers. Okay, or nodes. Okay, to set up all those things. Okay, so the Hadoop architect has given a plan like, okay, so hey, you need 5 master nodes of this capacity. Okay, 5 master nodes of this capacity. Okay, and okay. Okay, so
sir, is this production, sir? Production.
okay. Okay, think production only, sir. Think production only. XYZ Bank is a small bank. Okay, they have 4 sections. So their total data itself is only 500 TB data. Okay, they want to plan for a Hadoop cluster. So when they go to Architect, they have given this plan. Architect has given this plan. Okay, he told, okay, he or she told, okay, so you require 5 master nodes, 5 master nodes, okay, of this capacity, 60 worker nodes, okay, 2 edge nodes, okay. So okay, other nodes, okay. So here, okay, strong cluster. Okay, this is okay. So this is for security area, okay, or security tools. So for any others, okay, so altogether, okay, has given a plan for the 100 nodes, guys. Okay, are you clear till now? Huh? Are you clear till now? Okay, so now, okay, if you see, this is the overall disk is 2580 TB. Okay, to plan, okay, 500 TB data, I require overall disk capacity, overall, okay, 258 TB. And these are the cores, 3200 cores. Okay, and okay, this is the RAM. Okay, so in GB. Okay, understand? This is the RAM in GB. Okay, 35 TB of RAM nearly we have. Okay, this is the cluster capacity they have given. Now, okay, what is the next thing? So who will collect? Okay, who will go for this planning and planning? Normally, okay, so management will go for planning. Okay, so because okay, they are the people. Okay, so go to Architect and get a plan. Okay, now who has to implement this one? They'll recruit a Hadoop manager. Okay, so recruit a manager and tell, okay, hey, so this is the plan. As per this plan, okay, so as the manager, you need to set up this cluster. Okay, you need to set up the cluster. Okay, so what we will do now? Now, build a setup. Okay, to set up this cluster, how much time this guy require? Okay, we will see that. Okay, what are the different steps? Okay, we have here. Okay, so we have a manager. Okay, manager. Okay, so they told, okay, hey, set up this cluster. Set up this cluster. Okay, this is the cluster. Okay, they have asked him to set up. Okay, so now, okay, of course, okay, recruit manager and okay, team. Hadoop team. Okay, so now, what is the here? Okay, so Hadoop Architect has shared the cluster plan with the project manager. Okay, when he shared this plan, okay, he shared on 4th May. Understand? Okay, let's think like this. Okay, so today, okay, think that I'm the manager. Okay, so I have a Hadoop team. Okay, so my boss has given me this plan. Hey Venkata, this is the plan. Okay, you need to build a Hadoop cluster. Okay, with this capacities. Okay, so now what I will do? Okay, so today he has given the plan. Okay, what I will do? Maybe so project manager will share the plan with the procurement team with all approvals and budget. So now what I will do? Okay, as a manager, project manager, I will share this plan. Okay, with procurement team. Who is this procurement team? This is the team, okay, who will have, okay, normally contracts with the vendors actually. Okay, so again, okay, before going to this team, okay, we need to have all the approvals, right? Budget approvals and all, right? Okay, so now, so once, okay, all the approvals, okay, think that, okay, to take all the approvals, okay, manager has spent like around 5 days. Okay, on 9th May, okay, I got all the approvals and he sent a mail to procurement team, hey team, okay, as per this plan, okay, please procure these servers for me. Total, I need 100 servers. 100 servers. Okay. Now, okay, what procurement team will do? Procurement team will contact all the vendors for the quotation. Okay, so who are the vendors? Okay, when I say vendors, okay, so normally, so okay, HP, Dell, Cisco, IBM, okay, so they'll send a mail to all the people. Hey guys, okay, we need 100 servers. Okay, tell me how much okay you charge for this one. Okay, so maybe HP will tell, okay, I will give you this model. So for this is one server cost is this much. Okay, and Dell may tell like, okay, so hey, this is our server model, and okay, we give you okay this much warranty, this much price, okay, all those things. Okay, so everybody will send. Okay, so within a week time, okay, they usually this procurement team will give around 1 week time to come back with the quotation. Okay, so let's say when they send okay on 10th May, okay, they will take okay 7 days. Vendors will take. So now okay, they replied back. Some vendors may reply in 2 days, some vendors will reply 3 days, but maximum we will wait for 7 days as per the standard. Okay, after that what okay we'll do. So now we received okay all the quotations from all the vendors. Now okay, we felt that okay, Dell is better. Dell is giving okay, so servers okay in less time, first thing, less time in less cost, okay, and okay, it is giving more service, okay, and more warranty. Okay, so out of these vendors, okay, we finalized okay, let's go with the Dell. Okay, so finalize the vendor Dell and raise the purchase order. Okay, so now so on 17th May, okay, so because they have taken 7 days, right? Okay, now 17th May procurement team will send a mail to Dell team saying that, hey Dell, we are confirming you the order with you. Okay, so this is the purchase order. So we are signing and sending it to you. So you send me the servers. Okay, so now okay, so it is done. Okay, now time taken by Dell to prepare to deliver the servers. Okay, to deliver the servers. Okay, how much time okay Dell is taking? Okay, Dell is taking to deliver all the 100 servers. Okay, Dell is taking around 5 days. Okay, it means okay, so what Dell will do, so once they deliver, okay, so to whom they deliver, let's say there are new servers, okay, 100 servers are coming from Dell, to whom they will hand over. Okay, they'll hand over these servers to okay network team in the DC, okay, data center. Okay, so who is this network team? Okay, this network team also part of this team. Okay, so now Dell is delivering all the 100 servers to data center team. Okay, network team in the data center. Okay, when they delivered on 22nd May. Okay, so now how much time? Okay, so what is the work of the network team? Network team okay will put all the servers into racks and okay do the cabling part. Okay, and okay enable the adapters. So how many adapters you want, all the based on that okay they will enable adapters. So now okay, so these are the raw servers. Okay, no OS is installed, nothing, but still okay they can set up the IP address for this one. Okay, so now network team has taken around 5 days to complete this work. So once the work is done, network team will complete the cabling part and set the static IP for each server and hand over it to Linux team or build team. Okay, to do this one, okay, they have spent around 5 days. So finally, okay, on 27th May, all the 100 servers are handed over to Linux team. What Linux team will do? Linux team okay will do all the prerequisites. They'll install OS okay, and all the prerequisites. Okay, and okay, they take to complete all this work. Okay, they take around 2 days time. Okay, so this 2 days, 7 days, and all okay, they may increase based on number of nodes also. Okay, if you are building a cluster with only 50 nodes, okay, they may take only 1 day. Okay, or if you are building a cluster with 1,000 nodes, so they may take more time. Okay, I'm just giving again an example. Okay, for 100 nodes. Okay, so see now once okay the OS and okay, all Hadoop prerequisites are installed. Okay, then okay they will hand over this to Hadoop admin team. Okay, so now Hadoop admin team okay will take how many days? Okay, so Hadoop admin team okay will hand it over to okay. So in the Hadoop admin team okay you will have okay again DB team will install the databases. Okay, so they will take around 1 day time. Okay, so after that okay, so Hadoop admins okay will start installing Okay, we'll install Hadoop. Okay, configuration setup. Okay, and project onboarding. All these things they'll do. So normally to do this one, okay, they'll take 4 days. Okay, so it means okay. When you plan cluster today, okay, your cluster is ready to start, so configuration and okay, user onboarding. Okay, so ready to start. Hadoop cluster is ready to start. Okay, by developers. Okay, by Hadoop developers. Within how many days? On 3rd June. It means okay, if I start my planning today, okay, to see the cluster, the final cluster, okay, with all 100 nodes, okay, Hadoop installed, okay, Kafka installed, NiFi installed, Spark installed, okay, security installed, everything all together to see my entire cluster, okay, okay, to make my entire cluster ready, okay, I need 30 days. Will you agree with me? Will you agree with me, guys? Huh?
Yes,
So
sir.
here, what we are doing in these 30 days, okay, so we are buying servers, okay, we are going to vendor and we are buying servers, okay, so they deliver the servers, okay, to our data center. Okay, network team will arrange all the servers into racks and okay, do the cabling. Okay, then they'll hand over these servers to Linux admins. Okay, Linux admins will install the OS and then install the Hadoop prerequisites. After that, they'll hand it over to DB team. Okay, so DB team will install the backend databases. Okay, wherever you are using, whatever the backend databases you are using, DB team will install that. After that, okay, it will come to Hadoop team. Okay, Hadoop team will install Hadoop. Okay, and do the configuration setup and okay, do the user onboarding. Okay, user or group onboarding. Okay. Otherwise, okay, this one will be later. Okay, Hadoop. Okay, install Hadoop and configuration setup. Okay, it means okay. Now my cluster is ready to start use by developers. Okay, so to build my cluster, if I take all the things into consideration, it is taking around 30 days.
So this cluster will directly move to the production, sir, or any?
Think that this is a production cluster only, sir. But normally, okay, when you are building a cluster, okay, first what cluster you will build? You will build a test cluster. Then you will build development cluster. Then okay, you will build okay UAT cluster. Then you will build production cluster.
Yes.
Okay. So think that I am explaining about production cluster now. So all those 3 clusters are already built. Now I am talking about the production clusters.
Okay, sir.
Okay.
Fine.
Okay. So to build this production cluster, okay, I require 30 days. If I start my work today, after 30 days, I am seeing my first page. Correct or not? Huh? Correct or not, guys? After 30 days only. Okay. So now, okay. So normally, okay, so what is the data center, sir? Okay, so now, okay, so data center, okay, so okay, I'm just giving example, guys, okay, on-prem Hadoop setup here, actually, okay. So think like this, guys, okay. So here, okay, this is the building what we have, okay. This is the building what we have, okay. So this is the ground floor, okay. So normally where you have, okay, not we, okay. So it means like XYZ bank. I'm telling, okay. This is the XYZ bank, okay. Setup. XYZ bank. Okay. So data center. Building. Okay. Just building. Okay. This is XYZ bank building. Office building. Okay. So now this is the building. This office building has like a total thing. Okay. 8 floors. Think like this. Okay. 8 floors. Okay. So now, okay. So in the ground floor, normally securities and reception people will be there, and first floor, second floor. Okay, maybe think that okay, some employees are there. Okay. So in the 3rd floor, insurance project is running here. Okay, when I say insurance project, okay, you will have manager. team leader, okay, developers who work for insurance data. Understand? Okay, so these people, this entire team, okay, insurance project, it means, okay, entire project team, okay, manager, team leader, developers, okay, all these things, okay, will develop programs related to programs and jobs related to insurance project. In the same way, so loans project, okay, so and the fourth floor loan team is sitting, okay, so when it's a loans team, loans project team, okay, you'll have manager, okay, separate manager, separate TL, separate developers, okay, then, okay, you have, okay, credit card project and account project, okay, so these are the 4 places, okay, where, okay, 4 different teams are sitting, and okay, this is the place, 7th floor, so Linux team, build team, okay, DB team, okay, so here, okay, network team also, okay, or okay, maybe. Okay, so here, okay, this is the place where, okay, our Hadoop admin team is sitting. Linux build team, okay, DB team, Hadoop admin team. All the people are sitting here. This is a team, okay, where, okay, we manage this cluster actually. And okay, in the 8th floor, okay, you have in the 8th floor, okay, we are using like a data center. Okay, so data center floor. So you have 100 servers hosted in 5 racks. Okay, so here, okay, you have DC employees, normally network admin. Understood, guys. Okay, so it means, okay, when I say normally when I say office building, okay, so you will have, okay, employees sitting here and okay, data center also in one of them. Okay, that is the reason, okay, if you observe some offices, okay, they will say, okay, entry restricted for this floor. Why entry restricted for this floor? Huh? Why entry restricted for this floor? Because okay, it is a data center, so server room, okay, so this is, okay, server floors, okay, server rooms, okay, so entry restricted, they'll put boards, okay, but if you see in those floors, okay, you will see all the servers and all, correct or not, with the full cooling and all, AC and all. Okay, so when I say building, okay, so the building will have, okay, employees, okay, so this is, okay, this is the office building, okay, so let's say, so this is the office building, okay, inside this office building, it means, okay, you are keeping infrastructure inside your building itself, yes or no? Yes or no, guys? Okay, this is your, these are employees, okay, and this is your, these are your servers. It means, okay, XYZ bank is setting up all its 100 servers, okay, keeping, okay, the entire Hadoop cluster in their own project building. Okay, so this kind of model, this kind of setup of infrastructure is called as on-premises or in-house setup of Hadoop infra. On-prem model of Hadoop setup, Hadoop cluster setup, or in-house model of, okay, on-premises or in-house. It means, okay, so the servers, okay, the infrastructure, okay, will be completely available in your server building itself. Okay, or maybe, okay, so this is one example. Maybe, okay, so XYZ office has 2 buildings. Okay, in one building, okay, complete data center, other building employees will be sitting. That is also possible. Understood? Okay, so if you have, okay, your building like this, okay, so this is called as a on-premises model of infra setup. Any questions? Any questions here, guys? So now again, okay, if you want to set up on-premises infrastructure, okay, if you plan today, on average, how many days it is taking? On average, 30 days it is taking. Okay, after I got the plan, okay, plan from my architect, okay, if I start my work, okay, so it is taking 30 days for me, okay, to set up this one. After 30 days only, so slowly, okay, these people can start, okay, placing their data into Hadoop clusters. Okay, so it means, okay, all these people have to wait, okay, for 30 days to see the Hadoop clusters. Will you agree with me? Huh?
Yes, sir.
So this is called as in-house on-premises or in-house setup of Hadoop infra. Okay, so we'll stop it here, guys. Okay, we'll continue the rest of the things tomorrow. Okay. Thank you, guys. Thank you.
Thank you, sir. Bye.
Thank you, sir.